Now, we want to introduce to you, to all of you, the 6 Helmholtz Information and Data Science schools. They are the very pillars of the Helmholtz Information and Data Science Academy. They have been founded in 2017. 2017 was the call. 2018 we started the schools, and it is the largest structured post-grad program in information and data science for the natural sciences all over Germany, with 280 fully funded PhD positions, a good half of which is filled by now, or 2/3. So there's still lots of positions to apply for. That's all for all of you on the level close to your master's, or if you're still figuring out where to do your PhD, you can apply with all these schools. And these schools will be introduced to you by great scientists from those schools in the next session and in the session once removed after that. So for the first half of the Helmholtz Information Data Science School, I'm welcoming to the stage Professor Dr. Ralf Miekut from the Helmholtz Information and Data Science School from Health, speaking to us from the Karlsruhe Institute of Technology. So I'd like to have you with us, Ralf Miekut. Then we have with us from the Helmholtz Data Science School for Life, Earth and Energy, Professor Dr. Julia Kowalski from the RWTH Aachen. Hello, great to have you with us, Julia. And from the Munich Data Science School, our good friend and colleague, Marie Pirot, that has been introduced to you before, but I'm welcoming her more than gladly again to the stage. Guys, it's very great of you to join this virtual career day, to introduce these great grad programs that you not only designed, but brought victorious through the to the call for this substantial funding line. And I would love to start out with 2 minutes each to basically give us a rough overview about your programs. So, Ralf, do you want to start with the HITS for Health?
Okay, of course. HITS for Health is a joint cooperation between the 3 institutions, Karlsruhe Institute of Technology, it's my institution, German Cancer Research Center, DKFZ, and the University of Heidelberg. And I think the name is speaking, Data Science for Health. We have joined activities from the data science side, together with health applications. A lot of these health applications come from cancer research, as a German Cancer Research Center is involved, but we are not limited to it. For instance, University of Heidelberg has a very large clinic with also a lot of top scientists, not only cancer research, with a lot of health themes. And KIT is an institution with a lot of computer science activities, but also health activities or health-related activities in life sciences. And this team together make a lot of interdisciplinary topics for surgery of the future, for personalized medicine, and a lot of this data science activities is centered about image processing. I by myself, I'm an engineer by training and came over time with a lot of different applications into this field. I think it's enough for this short introduction.
Thank you, Ralf. Obviously, this is such a vast and fantastic field of innovation that we could talk about alone for hours, but a very fantastic example, bringing together the engineers, the computer science guys, and the health scientists in one grad program. Fantastic. Thank you so much. Next, Julia Kowalski, you want to introduce to us the HITS for Life, Energy, and Life, Earth, and Energy?
Yeah, thanks. So my name is Julia Kowalski. I'm a professor at RWTH Aachen University and PI, as well as steering committee member in the Helmholtz Graduate School HDS-Lee. So Helmholtz HDS-Lee stands for Helmholtz School of Data Science and Life, Earth and Energy, as we have heard several times now. As an international structured doctoral program, we offer an interdisciplinary environment for the education of the next generation of application-oriented data scientists. So our focus applications, as the name would suggest, is life science, earth sciences, and energy systems, as well as material sciences. And the question now is, why do we bundle all of these applications in one school? So all of the 3 domains generate huge heterogeneous data and rely on complex domain-specific simulation models. In future, research breakthroughs will require to combine, on the one hand side, domain-specific expertise with, on the other hand, the ability to navigate and leverage data and models. And HDSD is based on the idea that the exploitation of cross-domain synergies offers a great research opportunity. We hence work cross-disciplinary and cross-institutional. In HDSD, 5 partnering institutions come together: the Forschungszentrum Jülich, DLR, RWTH Aachen, MPI für Eisenforschung, and the University of Cologne. And we currently have 40 PhD students, 27 of which are financed through HDSD, and other PhD students who are associated. And our current PhD students come from a really wide range of different undergraduate study program backgrounds. So if you're interested, check out the webpage and don't hesitate to reach out.
Perfectly put pitch, but nevertheless, I mean, the life, earth, and energy, combining these questions together with one of the strongest technical universities of Germany, the Aachen University, is also a fantastic program. So thank you for introducing this it to us and the crowd. Marie, great to have you again, now with the focus on the Munich Data Science School. Could you introduce it to us in 2 minutes?
Yes, so the Munich School for Data Science, MUDS, in short, it's a graduate school for data science, which has 4 different tracks. So biomedicine, plasma physics, Earth observation, and robotics. And there are 5 partner organizations in MUDS, the TUM and the LMU, which are the 2 very, very large universities in Munich and among the best universities in Germany. And together with the Helmholtz-Zentrum Munich, so mostly for biomedicine, the Max Planck Institute for Plasma Physics, so for the plasma physics track, and DLR, which is also a Helmholtz Center, and they are partners for Earth observation and also the robotics tracks. One nice thing about doing a PhD at MUDS is that all PhD projects have to be supervised by 2 PIs, one which is like methods-oriented, and then a domain-specific PI. And I think this is a really nice feature that forces you to keep the balance in your PhD between the application and the methodology. And all students, they will get this also data science lectures, and this is, of course, in a very interdisciplinary environment, because they will get the data science lectures together with the other students. So there is a biannual call for PhD students with deadlines in April and November every year. And there you can apply to projects that have been proposed by the MUDS PIs, basically, and apply for a PhD there. And also besides this, there are also several open positions at various career levels at our department, at Helmholtz-Zentrum Munich, and also at DLR. In particular, PhD in biomedicine and robotics, and a postdoc in biomedicine and a statistical consultant position. So you can find them all at the MUDS booth later.
Are you still with us?
Yes.
Okay, perfect. Thank you so much. It was frozen for just a glimpse. Okay, so thank you for introducing this great school to us. I'm a very big fan personally of the MUDS because it's such closely tied to our artificial intelligence unit via the person of Marie Pirot. So let me remind all of you listening from all over the globe, there is a Q&A button on the side. So if you want to have a specific question to the guys introducing the first half of our great schools, please do not hesitate to post your question there. And let me remind you also of the button that says partner, where you will find more information and links to the programs themselves. So, but let me ask all of you, you introduced very, very unique grad programs here. So maybe 1 or 2 of the listeners are a little bit intimidated on oh my God, I have to know about life, earth and energy and computers, and then I can talk to Julia. Is that the case? I mean, what is the profile of an ideal candidate? I mean, all of your schools are trying to recruit heavily internationally, so this is your audience basically. What would be something that I should bring to the table to apply with you? Ralf, you want to start again?
Yeah, of course I can start. I think a perfect profile is a candidate who has a master program in computer science or physics, engineering with a strong focus on this data science side. We never expect that you have already experience with the domain, and we think it's more important that you have a solid background. It could be also mathematics, again, with such a data science, machine learning background. And you can expect that we have the same structure like in Munich, that we have 2 PIs that support this complete thesis. And you learn from both sides. You are, in our case, also associated with both groups and can learn from it. But this starting background is crucial, I think.
Interesting. And all I need to know domain-wise, you will teach me very fast, I assume. Great.
Julia, if you are a fast learner, of course, yes.
Well, aren't we all? Julia Kowalski, what is the ideal profile, or what is like a necessity that I should bring to the table when I apply with you?
Okay, so let's, because you told the audience, so let's start with what you don't have to be. So you don't have to be expert in life, earth, and energy, because typically a PhD student works in either of these application fields, right? So ideal candidates to us are computing in the sense that they have a strong methodological background, but that does not necessarily have to come from an applied mathematics, a computational engineering science, a simulation science study program. But we do also have candidates that studied within an engineering program, let's say biomedical engineering or chemical engineering. Effectively, the 40 PhD students that we currently have almost come with 40 different undergraduate programs, just to give you the width, right? What you do need, though, is an openness to interdisciplinary work, because most of the students that would enter our schools will build up a domain expertise, and they participate in courses on complementary aspects of data science. So they learn additional expertise during their stay in the school.
Thank you so much. And let me extend the same question towards Marie. What would be my ideal profile to apply with you in Munich?
Well, yeah, I have a similar answer to what has already been said. So you don't need to be an expert in plasma physics or biomedicine and so on. It's good if you have a good mathematical or statistical background and master in a related field. And but of course, in interest and the motivation for the topic that you are applying for, and this is also very important, because you will have to dig in very deep, to dive in very deep into this topic for 3 years. So you should have a strong interest, I would say.
Great. So we have a lot of similarity on that field. So let me summarize for the crowd listening. You don't need to know anything about what you are doing with your computers. You just need to know how to use it, and all the other guys will tell you how it can be put to best use in the programs associated. But let's talk about the differences maybe a little bit. I would love for all of you to name like one like highlight PhD thesis that's been carried out at the moment, like something that you're particularly proud of or excited about that's been going on in your school. Do you have like an example that we get like a little more understanding on what kind of research I'm promoting with my data science skills within your school? Do you have something? Does something come to mind maybe? A unique program where you say, that's very smart, I'm very excited about it. What the research is, what is a typical PhD thesis within your school?
I just take the answer here, right, Andreas? So I make a start here. So of course, I don't point towards a single PhD, but I do see that in our school, a lot of people are involved, or a lot of students are involved in the question of combining actually machine learning data science with complex simulations. And with that, we can push the limits regarding the predictive quality of whatever we want to simulate. And that is very interesting to see. So you wanted a very specific answer like this PhD project. And I unfortunately, I can't give it. However, let's say in the area of model-based decision support for geohazards, for instance, that's something, one example I'm particularly interested in. We made quite some progress, and that progress wouldn't have been possible without leveraging this whole machinery of applying machine learning to complex simulations. That's actually interesting to see.
I realized that my question regarding the most important thesis is very unfair with all your students potentially listening. So let me rephrase it for the other ones. Can you give us like a typical example of a PhD work being carried out? Not the best, but just something that gives a little more understanding or makes it a little more understandable what I would be doing for the 2, 3, 4 years that I would be joining your program. Ralph, can you give us an example? What would I be doing?
I will not focus to one thesis, but we have one typical type of thesis covers a lot of theses at the moment, that you have a relatively complicated data set based on images. For instance, could be single cells in 3D developing over time, or CT and MRI data with specific pathologies, and designing an image processing algorithms that can draw conclusions out of it for basic research, also for clinical analytics. And I think these kind of things is very important, which means you need a kind of standard of machine learning techniques, but bringing it into a domain and also try to increase explainability for experts, showing, for instance, variations in annotations or showing what could be an uncertainty. And this covers, I think, some of the theses, and is only one example, and all others. I could also tell different stories, for instance, for a combination of robotics for surgery and imaging and so on.
Fantastic. I mean, the explainability of AI-based system, obviously, that's a very tough nut to crack, and there's great career opportunities there as well. Marie, what about you? The stereotypical, like a standard, not standard, but what would be something that I might be working on? What kind of problem would I be tackling in your school?
So I will and also give a biased answer towards the biomedicine track in maths, which I know much more. And I would say that in our institute there is 2 different types of PhDs that you could do, Andreas. So there is a lot about medical imaging as well in Munich. So also, trying to make diagnosis directly with AI on imaging, also explainability. There is also a lot going on with how do you respect, for example, the privacy of the data? So in medical data, that's also a problem. How do you learn on these algorithms without being able to see the data because it's private? And federated learning, things like that. And in our institute, there is also many PhDs that have to do with so-called omics data. So this is very different types of medical data. And this is like very high throughput, so also very, very big data that you get when you start by sequencing the genome of single cells and looking, also sequencing the mRNA and so on of the single cells. And there is a lot of data science to do here as well to understand what is going on from a biological point of view. So this will be the other type of PhD that you could do with us.
Thank you, Marie, for giving us these insights. I've a question regarding like the infrastructure that is accessible for your school. I learned over the years that for a lot of people, the access to high performance computing, to clusters, to GPUs, to computing resources is something of great importance, and the attractiveness of like Google or something like that comes from the fact that you could actually access very state-of-the-art large computer resources. What is the situation within your schools? What do you have to offer computing-wise or computing resources-wise?
So maybe I can answer for us. We really make a lot of efforts so that this is not a problem for the PhD students and the AI consultants and so on. So we have access to different systems. Within the MUDS partners, there is the TUM, which has the LRZ, which is a very, very big computing center, and also the Max Planck Institute for Plasma Physics. They have their own, like a very large computing center. And in Munich as well, and in Helmholtz AI, there is also resources. This is not a problem. The computing resources should not be a bottleneck for your PhD.
Good to know. Ralf, what is the situation in Karlsruhe, computing-wise?
More or less the same. For instance, if you stay in Karlsruhe, you have the Steinbuch Center for Computing, which is one of the largest computer center in Karlsruhe. If I look out of my window, I see a big white building. This building is full of computer capacities, nothing else inside. And if you want, I can turn my screen in this direction. And you have also similar opportunities in Heidelberg and with the DKFZ and the University of Heidelberg, no problem.
And Aachen, can I do some great computing with you guys as well?
Yes, well, first of all, the school is centered in Jülich, which is well known for its compute infrastructure. But then also in Aachen, we have a compute cluster which can be accessed. It's not a problem. We also have local machines to develop stuff and then put it on the big machines. So access is not a problem.
All right. So I got the great interdisciplinary program, a fully funded position, and access to the best computers of the country. That sounds quite attractive to me, Danielle, doesn't it?
It does to our participants, and they have questions.
Go ahead.
So we have another physicist here. By training, I am an experimental physicist with some experience in nonlinear regression modeling and data acquisition. What is a good strategy to jump into a data science career? Anyone interested?
Who wants him or her?
Anonymous user.
Anonymous.
Yeah, I think it's no problem if you have a good theoretical fundamental. For instance, a lot of time series analysis has some standard programs, classification problems, regression problems. And my recommendation is hands-on, try to play with tools, try to play with your own data, try to get information out of it, and always play and look back to literature and look for other solutions. And also, if you don't have own data, there's a lot of great data sets in the world. Look to benchmarks, look what they use. And I think it's a good way with a mixture of lectures, inspiration from papers, and own experiments.
More questions?
We do. Niels Witznick asks, is there a group working with reinforcement learning? And are there opportunities to do research in that field? I'm sure there are. I don't know with the speakers here.
Anyone doing reinforcement learning?
Well, I would say I'm sure there are, but I definitely want to also point on the web pages where open positions are currently announced, at least on the HDSL side and probably also with the other schools. So the announcements give some information on the particular project and can be checked out for specific interests.
Marie, you are with AI, reinforcement learning. Is that a hot topic in Munich?
Yes. I also don't know of an opposite position right now, but definitely I'm also sure there are. Yes.
But I assume that somebody capable of reinforcement learning could get in contact with you, yeah?
Yeah, I would.
All the other great schools that utilize these technologies. One more question.
Here somebody asks whether how are the post-PhD career opportunities for international students in machine learning and AI? Do you have experience there yet? I know most of your students are still in the programs, but what do you say about employability later on?
I think it's really high. So I cannot speak for the PhDs directly, but I also see for the AI consultants in the industry, or also by going forward to academia. I think this is right now. It's just there is so many job openings that your employability will definitely be super high. I'm not an international or not. I mean, that's not an issue.
Super high.
That gives me the opportunity to point to our jobs database again. So if you go back to our reception area, for example, or you also find it in the chat, we have a link there that goes to our jobs database where you'll find all data science jobs at Helmholtz listed.
Several hundred of those. Okay, so that basically brings us to the end of this session. Let me point out to everyone that there is a partner button on this side somewhere, and you can find the portal basically, and the short introduction to all of the great schools that you learned at during this session. So, and let me thank the panel that was from Karlsruhe, Ralf Mikut, and that was from Aachen, Julia Kowalski, and from Munich again, Marie Pirot. It was fantastic to have you with us, and I thank you wholeheartedly for introducing these very, very attractive programs to the crowd. At 5:30, we will have a live partnering session. And if you want to talk to the people responsible for those schools directly, please be patient till 5:30 Central European Standard Time, summertime, and again hit the partner button, and then there will be live chatting opportunities with these great Helmholtz Information and Data Science schools. So thank you guys for joining us. I hope to see you soon again, and maybe even live. And everyone get in contact with these great PIs that introduce the schools to you.